In this video, we'll talk about rule number 7 for solving equations, which says that if you have an equation that has a variable inside of a square root, a variable, or more generally, a variable inside of any type of even root, which could be a fourth root or a sixth root, we want to try to isolate the root and then square both sides to get rid of the root. All right, so let's look at an example. So in part A, I got this square root of t plus 2 minus t equals -4. All right, so first I want to try to isolate that root. So I got square root of t plus 2. Let's add this t to the right. So we'll get t minus 4. And now let's square both sides. Okay, so I'm going to square the left side, square the right side. So when I square the left, it'll cancel that root, and we'll end up with t plus 2. On the right, to work out this thing squared, remember this thing squared means t minus 4 times itself. So now we got to distribute and FOIL that out. And that gives us t squared minus 8t plus 16. Okay, so now we can move everything to one side. So I'll move all the stuff on the left to the right, and we'll get t squared. If I subtract the t, we get minus 9t, and then we get plus 14. All right, so I got a quadratic, and let's try to factor this. So let's factor this. I know there's going to be a t. I know there's going to be a t. Two numbers I need that add to -9 and multiply to 14. So let's see, that's going to be -7 and minus 2. And now that it's factored, I can go ahead and say what t equals. So from the first parentheses, I get t is 7. From the second one, I get t is 2. Okay. It turns out I'm not done. There's something I still need to do, which is I got to check for what are called extraneous solutions. So we've seen that term before, extraneous. Extraneous means sometimes when I'm solving an equation, I can get extra answers that don't actually work when I plug them back in. And if I have an equation with a variable inside of an even root, that's a situation where we can produce extraneous solutions. And I'll talk about why later. But for right now, let's check these answers. Let's see if they work. All right, so let's check t equals 7. Let's plug that back in. So if I plug it into the original equation, I get square root of 7 plus 2 minus t, so minus 7 equals question mark. Is it going to equal -4? Put in a question mark there because I don't know if they equal each other yet. Okay, so I got square root of 9, which is 3. 3 minus 7, question mark equals -4. But now I can see the left-hand side is -4. The right is also -4. So this works. This works. I'll put a smiley face here. That one worked. All right, let's check this other answer. Let's test t equals 2. If I plug that in, I get square root of 2 plus 2 minus 2. And then equals question mark. Does this equal -4? Okay, so I got square root of 4, which is 2, minus 2. And that's going to be 0. And 0, well, 0 does not equal -4. So this one's not working. This one's not working. So t equals 2, I put a slash through it, and I write EXTR. It is extraneous. So I end up with just one answer, t equals 7. Okay, so let's take a look at another example. So part B, I got square root of t plus 2 equals -4. All right, so I want to do this one two ways. So method 1, what I'm going to do is do the same thing I did before. Let's square both sides. So I get square root of t plus 2 equals -4. Let's square both sides. Square this side and square this side. So on the left, it'll cancel the root and give me t plus 2. And then -4 squared, that's going to be 16. Okay, and then if I isolate the t, if I subtract the 2, I get t equals 14. So I get t equals 14. But if I check this, and I plug it in, I'll get square root of 14 plus 2. And does that equal negative 4? Well, no, because the left-hand side is positive 4. The right-hand side is negative 4. And those are not equal. Okay, so that means this answer, 14, this is extraneous. So I only got one answer. It ended up being extraneous. So that means there's no solution. There is no solution to this equation. Okay, so next, I want to show another way I could have recognized that it's quicker. So how could I, looking at this original equation, see that there's no solution? Well, I got the square root of some stuff, and I'm saying the square root of some stuff equals a negative number. But we know that when I square root something, this cannot be equal to a negative. The output of a square root is not allowed to be a negative number. So if I recognize that from the beginning, I could say, well, so as a result, this has no solution. This is just an impossible situation. A square root cannot end up being a negative number. All right. Okay. All right. So the question I want to return to now is, well, why can equations like this that have these square roots produce extraneous solutions? Like, why is that even a possibility? So I want to look at this example that we just did, square root of t plus 2 equals negative 4. And in method 1, we got an extraneous solution. Well, so if I look at this equation right here, after I squared both sides, I got t plus 2 equals negative 4 squared. And in the original equation, we have the square root of stuff. We got the square root of some stuff, but we know the square root of some stuff is not allowed to be equal to a negative number. But when I square both sides, squaring both sides removes a restriction. Namely, the restriction that when I square root something, I'm not allowed to get a negative number out. Because when I square both sides, that gets removed because that negative number now got squared, and now it's no longer negative. So squaring both sides got rid of that restriction. And when I remove a restriction like that, it opens up the possibility that we might get some extra answers that don't work. And that's what happened in this equation. We got this extra answer that didn't work. All right, so let's take a look at one more example here. All right, so part C, I got 2 square roots this time. So I'm going to start this one off by isolating one square root. Okay, so maybe I'll isolate the square root of 3t plus 1, and I'll move the other one over. So I got 1 plus square root of 2t minus 1. All right, and then now let's square both sides. So square the left, square the right. So on the left, it'll get rid of the square root. I'll get 3t plus 1. On the right, it is super tempting to say, wait, can I take that power and distribute it to both of these? But I cannot do that. I can't distribute a power when I'm adding or subtracting terms, only when I'm multiplying or dividing. So instead, I have to remember, this, when I square this thing, it means multiply it by itself. 1 plus root t, 2t minus 1 times 1 plus root 2t minus 1. I got to multiply it by itself. And then I got to FOIL it out. All right, so when I FOIL it out, I will get 1 plus 2 root 2t minus 1. And then multiplying the last terms together, those 2 square roots together, I'll get plus 2t minus 1. Okay. So now, well, one thing that's nice is this 1 cancels that minus 1. And now I only have 1 square root left in my equation. So let's try to isolate this remaining square root. All right, so let's move everything on this side over, like this 2t. Let's move it over the other side. So I'll subtract the 2t. That'll leave me with t plus 1 equals 2 times that square root. Okay. So if I wanted to take this 2 over here and divide it over to the other side, I could, and then square both sides. It would just give me a fraction, which isn't the nicest thing. But if I square both sides right now, I won't get a fraction. So let's square both sides now. I will square this side, square this side. All right, so on the left, I got t plus 1 times t plus 1. If I FOIL that out, we get t squared plus 2t plus 1. And on the right, I'm squaring. This time I am multiplying the two terms, so I am allowed to distribute the power. This will give me 2. This will give me 2 squared, which is 4. I get to square the 2, and I get to square that square root, which will get rid of the square root, and give me 2t minus 1. Okay, nice. So on the right side, let's distribute the 4 to get 8t minus 4. And then let's move everything over to one side. So moving it all to the left, I get t squared minus 6t plus 5 equals 0. All right, and I can factor this. I can factor this. I get a t and a t. I need two numbers that add to negative 6 and multiply to 5. That's going to be minus 5 and minus 1. And now I get that t is either 5 or 1. Okay, so nice. Still got to check for extraneous solutions. So I still got to check. Still got to check over here. Because I had an equation with a variable inside of even root here. I got to check. All right, so let's check each of these. So I got check t equals 5. So I'll plug it back into that original equation. In doing that, I get square root of 3 times 5 plus 1 minus square root of 2 times 5 minus 1. Question mark, does that equal 1? And if I simplify this, let's see, the first square root is the square root of 16, which is 4, minus, then I got square root of 9, which is 3. So 4 minus 3, does that equal 1? Well, yes, I got 1 equals 1. That's true. So I'll put a check mark. That one worked. Okay, let's test the other value, t equals 1. If I plug that into the original equation, I'll get square root of, let me just simplify it right away. If I plug it into the first square root, I get square root of 4. Square root of 4 minus the next square root becomes square root of 1. And does that equal, question mark, 1? Well, yeah, because I get 2 minus 1 on the left, which is 1. And 1 does equal 1. I'll put a check mark. So this time they both worked. They both worked. So sometimes that'll happen. Sometimes even when I do have to check for extraneous solutions, all of the answers may end up working. It's also possible that when I check for extraneous solutions that none of them work and I end up with no solution.